Ah, welcome back. Welcome back to example 2. Welcome back to example 2. Let's quickly try this as well while we are still solving how to solve or how to differentiate. How to differentiate. We are still in calculus. Let's see example 2. Example 2. Example 2 is similar to example 1. Example 2 is similar to example 1. Differentiate. Differentiate with respect to x if y is equals to x cube. Example 2 is similar to example 1. Solution. Solution. The rule again. The rule states y plus change in y is equals to what? X plus change in x. Y plus change in y is equals to x plus change in x. So then I can say y plus change in y equals to this. To respect to x means this x must carry 3. So I'll be having x plus what? Change in x. Since it's respect to x and the x is carrying what? 3. I'll put 3 here. Are we together? Now, by solving, I will have to expand this problem. You know, this bracket will now be in 3 forms because it's carrying 3. So, and if example 1 is carrying 2. But now look at it, we'll be having x plus change in x 1, x plus change in x 2, x plus change in x 3. So when you expand this 3, we have what? We have y plus change in y equals to, when we expand this 3, we have x cubed plus 3x squared change in x plus 3x change in x squared plus change in x cube. As a mathematician, you must know expansion in your brain. So, why expanding this bracket in 3 multiple places? The result will be this. Can you see? If you want to learn how to expand fast, you can meet with Pascal triangle. Pascal triangle. Pascal triangle means when you are starting with 1, then 1 will start, 1 will finish it. Are we getting? When 1 will start again, 1 plus 1 becomes 2. Then 1 will end it again. 1 will start again, 1 plus 2 make it 3, 2 plus 1 make it 3, 1 will also close it. This is Pascal. So this is for x squared, this is for x cube. So you can see this is for x cube. So as you can see, x cube 3, another 3, and what? 1. You can see 1 times change in x cube is change in x cube. That is how to expand. So by solving, as we solve in example 1, this y will come here again. So it's now become change in y equals to what? X cube plus 3x squared change in x plus 3x change in x squared plus change in x cube minus y. I will now recall again. That is, recall recall that y is equals to x cube. Recall that y is equals to what? X cube. So by solving, I will now say change in y equals to x cube plus 3x squared change in x plus 3x change in x squared plus change in x cube. This is now minus y. I told us in example 1 that this y has become a taboo to this x. We are only solving to respect to x, not to respect to y. So remove this y and put what? When y is equals to x cube. So remove this y and put x cube there. So we have minus what? Because this is minus x cube. So this one will take care of this. Good. So what we are going to be left with is change in y equals to 3x squared change in x plus 3x change in x squared plus change in x cube. Yes, so we can say divide all through by changing x. You have get me. So we have what? Change in x, change in x, change in x, change in x. Please don't forget to like, comment, and subscribe. So let's solve. We are learning. So once this change in x divide all through, this will cancel this. This will take care of this. You know, this one is 2 times of it, so one will take care of one out of the 2 times of it. Then this will take care of out of the 3. It will remain 2. Mathematics. So what do we have? We are left with change in y equals to 3x squared. Okay, because this has gone, then we are left with plus 3x change in x. X what? Just 1x, because this has taken care of one of this, it will remain 1. But here is having 2, so plus change in x squared. Now we are having change in x here appearing. Nothing to do again than to do was to apply limits. We say apply what? Apply limits. So we'll call it lim. Change in x should be equals to 0. That is, let change in x tends to 0. Let change in x becomes 0. So we now say change in y equals to 3x squared plus 3x. This will become 0 plus what? 0 squared. Right? So then we have change in y equals to what? Equals to 3x squared plus 0 times 0 is 0. The 3x times 0, 0 plus 0 raised to power 2, 0. So when you add this plus this together, it still give us 3x squared, right? So we can say dy dx, change in x will be here, change in x, change in x. Because we have said divide both sides by changing x, so this is it here. So it must show that we are using the change in x. So in order to give us dy dx, so dy dx will be equals to 3x squared plus 0 becomes 3x squared. So this shows that when you are differentiating y